Maryland University capstone. My name is Alan LaBelle, a senior electrical engineering major. I had a lot of electronics for the robot.
Hi, I'm Michael Collins. I'm a senior mechanical engineering major, and I worked on the drive system and mechanical structure.
Hi, my name is Brad Waback. I'm an electrical engineering major, and I worked on some of the programming aspects of this project.
Hi, I'm Joe Jennings, also an electrical engineer, and I worked on the AI for this project.
I'm Todd Federici, a mechanical engineer, and I worked on the mechanical structure and drivetrain. This is Matthew Schweinefus, a computer engineer, and he worked on the programming and AI.
And we are Team C3D2.
The objective of our project was to design a greeting robot for the new James Lehr Kennedy Engineering building here at ONU. The purpose is to present an extension of the new building as a technological wow factor. The robot will interact with prospective students and parents before, during, and after the tour to draw more interest towards our engineering program. Finally, this will show students what they can look forward to and what they can achieve during their time here at ONU.
The TiM 781 SICK LiDAR scanner is the main sensor used for this project. It is essential that the robot has an accurate mathematical representation as to what the surroundings are. The great precision of the SICK LiDAR scanner improves the security precautions so that the robot can see obstacles sooner and make decisions faster. By utilizing such an accurate sensor on the robot, it opens the door to many opportunities explained in the business aspects of this video. The main purpose of the scanner is to generate a map of the building so that the robot can maneuver through the halls while knowing its current location. After the map is generated, the LiDAR serves a second purpose, which is object detection and avoidance.
Before beginning construction, we produced full 3D models of the robot in Solidworks. The detailed models seen here assisted us in our fabrication process. These models were used to guide our machining and fabrication during the process of building the physical robot. Pictured here is the robot's base and drive system.
Now being shown is a simulation of the robot showing off its path planning and object avoidance that it contains using the LiDAR sensor. So as you can see on the video here, the little white box is the robot moving its way through a hallway in the James Lehr Kennedy first floor. The other blue dots that you can see are it avoiding the trash cans that were placed in its way. So this is simulating static objects that could be trash cans or furniture, or it could also be simulating something like a human walking in its path. And as you can see, the robot is adaptively adjusting its gray line, which is the path, to avoid these objects. And as it's working its way there, it's looking for that endpoint outside the hallway. Next being shown is the beta phase testing of the actual robot's motor box going under its inaugural test run. So as you can see, it does not move too fast so that people can walk with it, and the motor box is now currently allowed to move and will be continued testing further on.
The business aspect of any project is crucial to the success in the market. The first step is knowing what share of the market you may have. The tour guiding robot has many different uses across all aspects of life. Not only can it give tours of the engineering building at ONU, but also many other buildings on campus and other college campuses as well. Furthermore, it can be used to assist in airports by carrying luggage, directing travelers to their terminals, or even assisting those who are disabled by pushing their wheelchairs to the correct locations. A third important use for the robot is in a museum. The robot could guide patrons around and explain what each piece of art is and its significance as to why it's important in history. The versatility of the product would allow us to have a great share of the market as there is limited competition. Now I will move on to the money side of things. After purchasing on all of our materials and assuming a low-ball selling price of $15,000, the profit is still greater than $5,000. The return on this product could be immense for consumers. If this robot convinced only one student to attend a university, it would already have paid for itself.
To begin with our challenges, we have COVID, which delayed our parts in progress. As you can see in the video here, we spin out, which COVID delayed us fixing this error. Additionally, machining our own parts was very time consuming. The creativity of the robot was that we originally wanted a sheet steel shell. However, we switched to an acrylic clear shell so that everyone around could see the intricacies of the inside of the robot. Additionally, our AI questions are customized for ONU, face winks and blinks, and the mouth moves while speaking. Finally, we wanted to reiterate how honored we are that you allowed us to compete in your competition, and we wanted to say thank you.